So welcome to IQ Online Classes. So today I'm going to do friction and happy independence. Okay? So today I'm going to do friction. So I'm going to summarize this topic in a simple and easiest manner as possible. So I'll do this topic in question form. I'm going to answer exam questions while doing this topic here. Okay? So the first question here is, what is this friction? What is friction? Okay, so this is the first question here and the most important question here. So what is friction? Okay, so friction is just a force that opposes motion. Friction is just a force that opposes motion. So friction is a force that opposes motion. Okay, so friction is just a force that opposes motion. Okay. And this friction is given by this formula, say frictional force is equals to what? The coefficient of friction, which is mu, times the what? The normal force. Okay? This is what we call the normal force. Normal force here. And what is this? Mu, it's a Greek letter mu, which is the coefficient of what? Friction. Coefficient of friction. Okay, so this is the coefficient of friction here. So this is the most important formula here on friction. The frictional formula, or the formula for friction itself, is the most important formula here. So it's the most important formula here. Okay, let's go to question number 2. You see how we use this formula. Let's go to question number 2. Okay. List 2 types of what? Of friction. Okay. List down 2 types of friction. List down 2 types of friction. So we have 2 types of frictions here. So the first type of friction is what we call the what? The kinetic friction. Kinetic friction is also called dynamic friction here. Because it's changing, dynamic friction. Okay? Dynamic friction or kinetic friction is the type of friction that is possessed by a board that is in motion, a board that is moving here. Okay? Number 2, what we call static friction here. What we call static friction. Okay. This static friction can also call it what? Okay? Limiting friction. Can also call it limiting friction here. Also call it limiting friction. So the word static means not moving. So this is a type of friction that is possessed by a body that is not moving here. So this one kinetic when a body is moving, this one when a body is what? Is not moving. And this one, because we are talking about kinetic friction, so meaning the coefficient of kinetic friction will be given by mu, when you put a small k, meaning kinetic friction. And for static friction, it will be given by what? Mu s here. Okay. So these are the 2 types of friction, and it's a must, you have to know this if you have to answer a question on friction here. Okay. So let's go to the next question here. Let's go to question number 3. Let's go to question number 3 here. Okay. List down. Okay. List down 5 laws of what? Of dry friction. Okay. List down 5 laws of what? Of dry friction. So this one is usually asked in the exam. List down 5 laws of the what? Of the dry friction here. Okay. So number 1 here, the first one here is what? The definition for friction itself is the first law of what? For dry friction. So friction is a force that opposes motion. So that's the first law here. Say friction opposes motion. Friction opposes motion. Friction opposes motion. So, what do I mean by friction? Let me explain friction in a simple term. So, friction is just the roughness of the surface. So, for friction to take place, meaning the surface should not be smooth. Okay. So, the first thing here, friction opposes what? Motion here. Okay. Number 2, friction. Friction depends on the nature of the what? Or the surfaces in contact. Friction depends on the nature of the what? Surfaces in contact. Friction depends on the nature of what? Of surfaces in what? Surfaces in contact. So friction, contact, okay. On contact. So friction depends on the nature of the surfaces in contact. What do I mean by the nature of surfaces in contact? Is the surface, are these surfaces smooth or what? Or that? Okay. Smooth here or what? Okay, so here we are talking about the nature of the surfaces. Are they smooth or not smooth? That's what we mean. Friction depends on the nature of the surfaces in contact here. Next, which is number 3 here. Friction depends on the type of the surfaces in contact. So friction depends on the types of surfaces in contact here. So friction will depend on the nature of it will depend on the types of surfaces in contact. What do I mean when I say types here? So we are talking about, is it wood? Is it metal? Something like that. Is it plastic? Is it metal? Is it wood here? Okay. So what we mean, the types of what? Surfaces in contact. So on the nature, we're talking about the smoothness or the roughness here. But on the types, we're talking about, is it metal? Is it wood? Is it plastic? What type of material is that? Okay? Let's go to number 3. To number 4 here. To number 4 here. Friction is directly proportional to the normal force. So you can see for the formula here, friction is directly proportional to the normal force here. So friction is directly proportional to the what? To the normal force. The normal force here. Friction is directly proportional to the normal force, as simple as that. So let's go to the last one, which is number 5. So friction is independent of the following here. So friction is independent of number 1 here. So start by what? The sliding speed is independent of what? The sliding speed there. Number 2, friction is also independent of what? The area of the surfaces in contact. The area of the surfaces in contact. Surfaces what? In contact there. Okay, as simple as that. Okay? So number 1, friction opposes motion. Number 2, friction depends on the nature of the surfaces in contact there. Is it smooth? Is it rough there? Number 3 there, friction depends on the types of surfaces in contact. Is it metal? Is it wood? Is it plastic or any material? Number 4 here, friction is directly proportional to the normal force. And the last one there saying friction is independent of these things. Number 1, sliding speed. Number 2, the area of the surfaces in contact there. Okay, so it's a must, you need to know this. They usually come in the exam. Okay, let's go to question number 4 there. Let's go to question number 4. Let's go to question number 4. Let's go to question number 4 here. Okay, so number 4 here, they say, state 3 advantages and disadvantages of friction. Disadvantages of friction. Disadvantages of friction. Disadvantages of what? Of this friction here. Okay. State 3 advantages and 3 disadvantages of friction here. Okay. Number 1, let's talk about the advantages there. Advantages there. Okay. So the first advantage for friction here, friction enables walking. So friction enables walking. Enables walking here. We are able to walk because of friction. Because I said friction is just the roughness of the surface here. So if the surface is smooth, you can easily fall down. But because friction is the roughness of the surface, we are able to walk without slipping because of what? Of friction there. So it enables walking. So number 2, so friction is used in machine and vehicle braking system. And vehicle braking system here, a simple braking system. Okay, so friction is used in braking system. Okay, then number 3 here, what do we talk about on number 3 here? So friction facilitates gripping of objects there. Gripping of what? Objects. Okay. Gripping of objects. So we have 3 here, we have 3 advantages here. Let's talk about disadvantages. Let's talk about disadvantages there. Let's talk about disadvantages. Okay. Let's talk about disadvantages here. Let's talk about disadvantages. Okay, so let's add the fourth one here, say use of heat generation. Use of heat generation here. We generate the use of heat because of friction there. Use of heat. So I've added this word use of here because I'm talking about the needed heat. The needed heat. When it goes beyond what we need, it becomes what? Excess heat. But here we're talking about the what? The use of heat. Okay? So now let's talk about the what? The disadvantages here. Disadvantages. Disadvantages here. Advantages, okay. Okay. Disadvantages here. So let's talk about the disadvantages of friction here. So the first one here, let's talk about the first one here, the first disadvantage here. So here we say that friction enables walking, right? So friction will enable walking. But for you to move, for example, where I'm standing here, for me to make a movement here, I have to push myself so that I move. Okay. And at a certain point as you are moving, you get tired. Do you know why you get tired? Because there's a force that is opposing you. There's a force that you can see that is opposing you in front. Okay. So meaning, for you to cause motion, for you to cause movement, you need to push yourself. So meaning, you need an external force to cause what? Motion. You need an external force to cause motion. You need an external force to cause what? To cause motion. You need an external force to cause motion. So you need an external force for you to move. You need to push yourself at a certain point to get tired. Okay? So number 2 here. As I'm moving here, because this surface is not smooth here, you can hear the sound of my shoes here. As I'm moving here, because this surface is not smooth here, you can hear the sound of my shoes, or when machines are lapping each other, because of friction, you can hear the noise or what. Okay? So meaning this friction, this same friction will cause noise pollution here. So this one will cause what? Noise pollution. Noise pollution here. Okay, so friction will cause noise pollution there. Okay? And again, as I'm moving, or as you move, because the surface is not smooth, you discover that your shoe is finishing. You discover that your shoe is finishing. Because the surface is not smooth, okay? Then you discover that your shoe is finishing there. So this friction will cause tear and wear. Tear and what? And wear. Cause tear and what? And wear there. As simple as that. So number 4 here. So here we talked about use of heat generation. But at a certain point, we have excess heat beyond what we need. So there's generation of excess heat here. Excess heat generation. Generation. As simple as that. Okay. So these are the 4 advantages and 4 disadvantages of friction. So if you have to pass an exam, you need to master these and you need to know them by heart here. Okay, let's go to the next question. Let's go to the next question. This is question 4. Okay. Let's go to question 4. Okay, question number 4. This is 4 here, 5. Okay. List down 3 ways. 3 ways you can reduce friction. You can reduce friction there. Reduce friction. Reduce friction. So list down 3 ways you can reduce friction there. So list down 3 ways in which you can reduce friction there. List down 3 ways in which you can reduce friction. So the first one here, we use stars, we use Roman numerals. So the first one here, you can reduce friction by what? Making the surface smooth. So making the surface get smoother. Okay. Because we said that friction is the roughness of the surface. So how do you reduce friction? It's making the surface a little smoother or making it smooth. That's the first one there. What's the second one here? Second one here, okay. We use some too. So here let's talk about what? Lubrication. Okay. Lubrication, the use of lubricants there. So lubrication, okay. So number 3. Number 3 here, you need to making the object more streamlined there. Okay? More streamlined there. Okay, more streamlined there. So what do I mean here? So making the object more streamlined there, what do I mean here? So a streamlined shape or a streamlined shape is a shape that allows air and water to move around it easily. Okay? Therefore reducing resistance there. Okay? So I'm saying a streamlined shape here. Shape is the one that allows air and water to move around it easily. Okay, so making the object more streamlined there. A streamlined shape is one that allows air or water to move around it easily. Okay, number 4 here, let's talk about you need to reduce the frictional force acting between surfaces in contact here. So reducing the normal force acting between surfaces in contact there. Surfaces in contact. Okay, reducing the normal force acting between surfaces in contact there. That's also will reduce what? The frictional force here. Okay. So, and I think these are enough. So here on lubrication, that's where you find things like putting these. Polishing. Okay. Okay, and I think these are enough. Okay. So they are enough here. Talk about 3, now there are 4 here, so you need to master them. You need to master this if you have to pass the exam on friction here. So it's a must, you need to master this here. Okay, so what else can we talk about on friction there? So what else can we talk about on friction there? So I think I'm done on all definitions and all the possible questions they can ask you on friction there. So now we can try to do some calculations, 1 or 2 calculations there. But in my previous videos, I explained on all the calculations or everything you need to do on these friction questions here. So let me put a question on friction there, or let me try to explain what happens on friction there. Okay. Okay, so on friction here, the most important formula is the formula for friction itself. And if you know how to manipulate or modify that formula for friction, then you can answer any question on friction here. But here, according to me, if you want to answer any question on friction, any calculation questions on friction here, always use this formula set. You know that frictional force is equal to what? The coefficient of friction, which is the mu, times the what? Times the normal force here. But to make your calculations more easier here, always make mu, which is the coefficient of friction, the sum-vector formula here. So over what? Over n here, over n here. So meaning this n and this n will go here when we have what? Mu is equal to what? The frictional force over the what? Over the normal force here. So I've made the mu, which is the coefficient of friction, the sum-vector formula. Always do this. Always do this if you have to answer any question on friction here. If you have to answer any exam question on friction here, always do this. So the moment you do this, just know that you're one step away from getting the correct answer there. Always make mu the sum-vector formula here. Okay, so let me explain this one in detail by answering a question here. So we need to understand the difference between push and what? And pull. We need to understand the difference between push and what? And pull. And there are certain terms we need to understand here. Okay? And there are certain situations we need to understand here. Okay. Okay. So what do we need to understand here? So for example here, I have this box here. Let's say this is the what? The horizontal surface here. It's the ground here. Okay. And you want to push this box here. You want to push this box of 10 kg here. And you want to push this box here. You want to push it here. Let's say this is your force with 20, maybe with 20 newtons. You want to move this box here. But if this surface is rough here, so meaning you have what? The frictional force. And what is the frictional force? The frictional force is the force that will oppose motion here. So meaning, if you want to move this box in this way, and if friction is the force that opposes motion, so meaning it will face in this direction here. So frictional force will face in this direction here. And always here, up here, always on each and every free body diagram, we need to have what we call the what? The normal force here. And what do you have here? We have the weight of this box here. And how do you calculate the weight? We know that the weight goes to the what? The mass times gravity here. So meaning what is the mass? 10. And what is gravity? 9.81 there. And what is the answer here? What is the answer here? It is 98.1 newtons there. Okay. So meaning here of what? 98.1 newtons there. As simple as that. Okay. So now here, I want you to understand this. I want you to understand this here. This up and down here we got the vertical, and this way and this direction here we call the what? The horizontal. This is the horizontal, this is the vertical. Vertical is up, down, the horizontal is in this way here. Okay. So now, if you are told to find the frictional force there, if you are told to find the frictional force there, you need to understand what we call the number and there, okay, or the x, y axis here. Okay. So here you know that x is what? Positive. X is here, negative. Okay, this is x here. And y here is what? Positive. Y here is what? Negative here. So here, how many forces do you have in the horizontal? You only have 20 newtons and what? And the frictional force here. So you can see that the 20 newtons is pointing in this direction where x is towards where x is positive. So we get to say 20 newtons. And this frictional force is pointing towards this direction where x is negative here. So meaning you say minus frictional force is equals to what? To 0. The summation of all the forces in the x direction should sum up to 0. And here, if you are taught to make an equation for the frictional force, 20 is equals to this one will jump to what? Frictional force. Okay. So what am I trying to say here? So here what I'm saying that if you only have two forces in the horizontal or in the vertical, and they are facing the different directions, just know that they are equal to each other. So in this case, no need to calculate anything. You know automatically the frictional force goes to 20 newtons here. Because we only have two forces in the horizontal facing different directions. You can do this mathematics to prove that they are equal to each other. Okay? And here, of the normal force and the what? The weight here. Because we only have two forces in the vertical here going up and down, and their force facing the different direction, meaning the normal force equals to what? N is equals to what? 98.1 newtons. They are simple as that. Okay. So you need to understand this. Okay. So this one you need to understand it is a must for you to answer any questions there. Okay. So now let's talk about something else here. Okay. Let me talk about something else here. Okay. So here on friction, there are two terms we need to seriously understand here. We need to understand them. You need to understand what is it to push, what is to pull, and what is to push. So we need to understand them if we are to answer any question in the exam. And simple, you can easily understand those things. They are simple and straightforward here. So let me talk about push. Instead of you pushing like here, you have this box here. Instead of pushing like this here, you decide to push this box at an angle somewhere here. So these are the questions they ask in the exam. Pushing and pulling at an angle there. So pushing and pulling in at the angle there. So let me try to demonstrate what is it to push and pull. So what is it to push and pull there? Okay? What is it to push and pull there? Okay. So pushing is like this. I want to move this table towards this direction. So pushing is like this. I push like this. Okay? I'm pushing. This is pushing here. And what is pulling? The main idea here, or the main goal is to move this box in this direction, or this table in this direction. So pushing, I'll push it like this. But what is pulling? Pulling, I'll move here. I'll come this side. I'll hold it here. I'll pull like this. But the main goal is to move it in this direction. So pulling is like this. Pushing, you pull like this. You push like this. And pulling, you pull like this. So you need to understand the difference between push and pull. But the main goal is to move this table in the same direction. Pushing, I'm pushing this direction. Pulling, I'll come here, I pull like this. So we need to understand those situations there for us to answer a question there. You need to understand those situations there for us to answer a question here. Okay, let's start with push. Let's start with push here. Okay, push. So we have this box here. Okay, and you should be careful. This question will be asked in word form. I have this box here, and let's say this is what the horizontal surface here. Okay, and this surface is not smooth here. Okay, when we say this is what 10 kg box there. Okay, then instead of the main goal here, you want to push this box, you want to move it in this direction here. Instead of you pushing here directly, you decide no, let me push this at an angle. Let me push this at an angle here. So let me push, maybe you want to push it here. You want to push it here. Instead of just pushing it like this, you decide to push it like this at an angle here. Instead of just pushing like this straight, you decide to push it at an angle here, okay? So let's say we are pushing it for speed here. And what we have here, always here have what? Normal force. It's a mass, never leave out the normal force here. And what we have down here is a mass of the weight. And the weight was mass times gravity, 10 multiplied by 9.8 is 98.1 newtons here. Okay. So if you want to push this box in this direction, you want to move it in this direction, the frictional force will oppose you, meaning the frictional force will oppose you. It will face this other direction here. Okay. Okay. And this push here, it can be anywhere, even here. As long as it's making an angle with the horizontal. It can be anywhere. Okay? So meaning here. And let's make a question out of this set. Question here. So they ask exam questions. Given that the coefficient of friction, given that the coefficient of friction there is what? 0.2, find force P or the effort there. Force P or the force needed to move this box in this direction. So given that the coefficient of friction is 0.2, find force P, this force here. Okay. Find this force P here. So the first thing here, the moment, and here what they will do, they will even give you the angle, say you are pushing at an angle of this and this. You are pushing at an angle above the horizontal of this and this. So say here we are pushing at an angle, okay? Let me draw a straight triangle. You are pushing at an angle of what? 20 degrees here, okay? You are pushing this direction here, 20 degrees here, okay? Then they tell you, given that the coefficient of friction is 0.2, find for speed there. Simple. So what comes in your mind when you see a force given at an angle there? So that's why in engineering science, I think the second topic is vectors, because they're introducing you to such situations here. They're introducing you to, or preparing you for these situations here. Okay. So when you see a force given at an angle, that's why I have what you call the vertical and the horizontal component. You have the cos and the sine component. That's why you do vectors. They are preparing you for such things there. Okay. So the moment you see a force given at an angle here, this force P is given at an angle here, meaning there's a vertical and a horizontal component. Meaning there's a vertical and a horizontal component here. So watch here. We are pushing like this. It's more like you are pushing, you are applying the force going down here. You are applying the force going down, meaning there will be this vertical component will go down because your force is going down, you are applying the force going downward, and the horizontal components will go towards your what? Your push will go towards the box there. Okay. So it's a must, you need to understand this. It's a must, you need to understand this. Okay? It's a must, you need to understand this. And these directions are very important because we are pushing like this, we are applying your force going downward, meaning the vertical component will go down here because your force is going down. You go down here, then the horizontal components go towards your push or towards the box here. Okay? And here always, the side opposite to the angle is sine. Doesn't matter if it is the horizontal vertical, the side opposite to the angle is sine here. So the side opposite to the angle is sine, so this one will be P. Sine what? Sine 20. Okay? Meaning, automatically this one will be cos. P cos what? 20. As simple as that. So the moment you manage to make these forces here or to apply all the components here, meaning we are done with the question and the question now will be straightforward here. So meaning you need to understand the components here. So when a force given at an angle, automatically there's a vertical and a horizontal component, and always the side opposite to the angle is sine, and this one should adjust this cos. Doesn't matter if this side opposite to the angle is in the horizontal vertical, it's always sine there. It's always sine. So now you can answer the question here. From this given information now, you can answer the question. But the most important question on friction is to be able to draw and interpret this diagram here for push. And this diagram, they don't change. As long as it's pushed on the horizontal surface, it will be like this, they'll only change the value. So if you can master this or if you can understand this better, okay, because it won't change. And if you know this one by heart, you won't even struggle, you know, it's just a matter of replacing the values there. Okay, so now let's find force P. Let's find this force P here. So how do you find force P here? I said the first thing you need to do is to introduce the formula for friction itself. So I said the frictional force was the what? Mu multiplied by the what? The normal force, as simple as that. And what's next there? You need to make mu the Sabito formula. So over what? Over n here, over n here. So this n and this n will go there. When you say mu equals to what? The frictional force over the what? The normal force. Simple as that. Okay. As simple as that. So now, the moment you make this formula, make me the Sabito formula, just know that you're halfway done. You're almost there. Okay? What's the next thing here? We are given that the coefficient of friction is 0.2. So this mu represents the coefficient of friction. So we need to put it there. So let's put it here, say 0.2 is equal to what? The frictional force over the what? Normal force. Good, simple. Okay. So now here, the key is making an equation for the frictional force and the equation for what? For the normal force here. So how do you make the equation for the frictional force? This is very important. And how do you make the equation for the normal force? Very important here. Very important here. So here, you know that the frictional force is in which direction? So you can see that the frictional force, which is this, is in the horizontal here. The frictional force, which is this, is in the what? In the horizontal there. So meaning to make an equation for this frictional force, you have to do all the forces in the horizontal. All the forces that are pointing this direction and this direction. This is the horizontal. The forces that are pointing here and here, you need to do them. Including friction itself here. So how many forces are in the horizontal here? So you can see that there is this P constraint is facing this direction and this frictional force is facing this direction. So meaning in the horizontal, you only have this force and this force here. And what did I say when you have two forces in the horizontal and they are facing a different direction? So when you only have two forces in the horizontal and they are facing a different direction, meaning they are automatically equal to each other, no need to calculate. So frictional force goes to P constraint. Okay? So say 0.2 here equals to what? P equals 20. Okay. So you know that the frictional force goes to P equals 20 because we only have two forces in the what? In the horizontal. As simple as that. Okay? So now the next move is what? To make an equation for what? For the normal force, this normal force here. So we need to make an equation for this normal force here. We need to make an equation for this normal force here. Okay. So how do you make an equation for the normal force or N? So you come to this diagram, this free-body diagram, which is very important in our case. You look in, the normal force is in which direction? So the normal force is in the vertical. It's pointing upwards in the vertical. So meaning to make an equation for the normal force, you need to drift all the forces in the what? In the vertical. You need to drift all the forces that are going up and down here. You need to drift all the forces that are going up and down there. So meaning how many forces are pointing up and down here? How many forces are pointing up and down here? So you can see that 1, 2, 3. These are the forces in the what? In the vertical. 1, 2, 3. So these are the forces that are pointing up and down here. And what do you do if you want to make an equation for the normal force? So to make an equation for the normal force, you drift all the forces that are pointing up and down, including the normal force itself. But here we have three forces that are pointing up and down. What do? The forces that are facing the same direction in the vertical, you add them. Add them. Doesn't matter if they are pointing in the negative direction, all you need to do is to add them. So meaning all the forces that are pointing the same direction, you need to add them. So you can see that this P sin 20 is pointing down and this 98.1 is pointing down. So when you add them, they'll be equal to the other force or the other forces that are pointing in the other direction here. So meaning in this case you have what? P sin 20 is pointing down, plus this other force is pointing down here, plus 98.1 is equal to the other force that is pointing in the opposite direction in the vertical, which is the what? The normal force. As simple as that. So meaning the normal force is equal to this. So meaning this is the equation for the normal force. Okay, this one was straightforward. Okay, so meaning where there's normal force, we put this P sin 20 plus 98.1. As simple as that. Okay, so the moment you do this, you can even start smiling because now you're just doing again one mathematics here. You can cross multiply here. You say 1 times P equals 20. So P equals 20. Okay, then to be 0.2 multiplied by everything down here, which is P sin what? 20 plus what? 98.1 there. As simple as that. So now all you need to do is to do the mathematics. Do you have a calculator? So what is here? What is cos 20? Okay. So what is cos 20? So you say 0.2 multiplied by everything. Yes, I say 0.2 open P sin 20 plus 98.1 here. Okay. Then you say what is cos 20 here? So cos 20 is 0.93 96 92 621, something like that. Then don't forget the P here, okay? Then is equal to what is 0.2 multiplied by sine 20? 0.2 multiplied by sine 20 is 0.0684, okay? P, okay? Then plus, what is 0.2 multiplied by 98.1? 0.2 multiplied by 98.1, okay? 0.2 multiplied by 98.1 here. 98.1, which is 19.62. Okay, 19.62 there. Okay. So let me bring it this side here. Let me bring it this side. Let me bring it this side here. Okay. So have 0.9396 there. 92621p there. Then being equal to 0.0684p plus 19.62. Okay. 0.0684p. Okay. So what do you do next here? Just group the right term. So meaning this one will jump to this other side. So it will be 0.93969261 there minus 0.0684p. Okay, there's p here. Is equals to what? 19.62. Okay. So meaning here we can subtract. So to 0.93969261 minus 0.0684. So this one will give us 0.87129261 p equal to 19.62 here. Simple. Okay. Then what's next? We want to remain with p. Divide both sides with this one. 0.87129261. Okay. The same thing here. 0.87129261 there. You divide there, which is 19.62. Divide by 0.87129261 there. So the answer here is P is equals to what? 22.52 newtons in this case. Okay, as simple as that. So this is how you do calculations here. That's how you do calculations here. This is for push, okay? And in the other video I did for pull. So in the other video I did for pull. So now I can leave you with a free body diagram for pull. I want you to try, okay? I want you to try there. I want you to try for pull, but I'll give you a free body diagram for pull here. So let me give you a free body diagram for pull. So let's talk about pulling here. The same question. Let's talk about pull. So we have this box here. Okay, this is the horizontal surface here. Okay, this is 10 kg here. What we have here is the normal force here, and here what the weight is 98.1 newtons here. Okay, and here pushing, you are pushing at an angle like this, but for pulling, you come this other side, you pull like this. This is P here. When you pull at an angle, say the angle is what? 20 degrees here. Okay, 20 degrees. This is 20 degrees there. You are pulling is like this. You are pulling. The main idea is to move this box in this direction. So if you are pulling, you want to move this box in this direction, automatically the frictional force will be here. You can put the frictional force anywhere, even here, as long as it's pointing in this direction here. Okay? So what's next here? Because you are pulling like this force given at an angle, meaning there's a vertical and a horizontal component. But for pulling, you are pulling like this. Pulling like this. So meaning the vertical component to go up. For pushing, you are pushing like this, the vertical component to go down. So meaning you have this component that will go up here. Okay? And this other one, you are pulling like this, will follow you. So this one in this direction. Very important. And the side opposite the angle is what? P sine what? 20. And this one P cos what? 20. Okay. As simple as that. So I made the free body diagram for Poo. This is Poo on the horizontal surface here. This is Poo on the horizontal surface. As simple as that. Then they can ask you the same question there. They can ask you the same question there. So say, question is given the coefficient of friction 0.2. Find force P. Force P. And all these questions they bring them in the exam. They'll give you the same scenario, then they'll tell you to find for pull and for push. And they'll carry somewhere 15 marks, just 2 of them. Sometimes even 20 marks, just 2 of them. They'll bring them together for push and for pull. They give you the same scenario, they say find the answer for push and for pull. Okay? So here, again, the most important thing is the formula for friction itself. So the formula for friction itself, I won't finish it, I just want to make an equation for you. Okay? So meaning, you make mu the Sabitov formula equals to what? Frictional force times what? Over the normal force. So what is the coefficient of friction here? 0.2. 0.2 there. B equal to what is the frictional force? And again, you start making the equation. The frictional force is in the horizontal. So you do all the forces in the horizontal. How many forces are in the horizontal? 1, 2. And when you have only 2 forces in the horizontal, meaning they are equal to what? To each other. Automatically, frictional force goes to P cos theta again. P cos what? 20 over. Now you need to make an equation for the normal force. The normal force is in the vertical. So what do you need to make an equation for the normal force? You need to do all the forces that are going up and what? Down. The forces facing the same direction, you add them, then they'll be equal to the other force. So in this case, you're seeing that the normal force and this P sine 20 are facing the same direction. So you need to add them. Normal plus P sine what? 20 is equal to the other force facing the other direction, so this one. 98.1. As simple as that. So now the main goes to make friction of N the Sabitov formula. Normal force Sabitov formula. So N is equals to 98.1 minus this one will jump with minus P sine what? 20. As simple as that. Let me just put it here. 98.1 minus P sine what? Sine 20. Okay. Sine 20. Okay. So this is an equation here. And again, you can do the normal mathematics, cross multiply, then you easily find force P there. You easily find force P there. Cross multiply, which would be this one times this one, P cos 20 equals to 0.2 multiplied by 98.1 minus P sine what? Find 20. Okay. Then you start multiplying there, you find P. You easily find P there, simple and straightforward. You find P, find what is cos 20 here, what and what, you find cos P easily. So this is just the idea here. So as long as it's push on a horizontal surface or pull on a horizontal surface and you are pushing at an angle, these diagrams would remain the same and they will never change. They will only change the values. So if you know this better, if you understand this better, then you are ready for the exam. In the next video, I'm going to do for inclined planes, for push and pull in inclined plane, then we are sealed and done for friction and we are even ready for the exam. Okay, then we are even ready for the exam. So thank you for watching. See you in the next video.